Hi everybody, Kailash here, and today we'll be discussing about finding the nth term of an arithmetic sequence. So here we see this formula for finding the nth term of an arithmetic sequence. Let's break this formula down and see what each variable represents. So let's start on the left side. On the left side we see this variable a sub n, and this is basically the value of the nth term that you're going to find. Now moving on to the right side, we're going to see a sub 1. A sub 1 is the very first term in a sequence, and in this case it would be 3 because it's the very first term in the sequence. Then we move on to n. N is basically the position of the term in the sequence. For example, in this one it'd be the 10th term, so like the 10th number. Then we see d. D is the common difference in the sequence. So basically you would see that the common difference between 3 and 6 would be 3, 6 and 9 would be 3, 9 and 12 would be 3, and 12 and 15 would be 3. So these are the common differences, so the d would be 3. Let's start with step 1, defining all of these variables and setting a value for them. So step 1, assigning values. Okay, so we see that a sub 1 would be 3 because it is the first term in the sequence. Then we see that n is 10 because we want to find the 10th term of the sequence. So n is equal to 10. And we see that d is 3 because that is the common difference between all of these numbers in the sequence. So d is equal to 3. Now we move on to step 2. Step 2 is plugging in these values for in the equation. So step 2, plug in values. Okay. So what we want to do is we know that our formula would be we know that our formula is a sub 1 plus n minus 1 into d. So what would be your first term in the right side of the equation? It'd be a sub 1, which is 3. So a sub n is equal to 3 plus n, which is 10, minus 1 into 3. Okay, so now that we've plugged in our values, we move on to step 3, which is simplifying this equation. So step 3, simplify equation. So what we do is, using order of operations, we would first multiply the 10 minus 1 and multiply the 10 minus 1 difference by 3 and add 3 to it to find a sub n. So it would be a sub n is equal to 3 plus 9 times 3. So a sub n is equal to 3 plus 27, and a sub n is equal to 30. So right now what we've done is we've defined all these variables, we've plugged in these values, and we simplified the equation. If you've had any trouble following along, just rewind the video and you can watch it again, but these are the steps to finding it. So we find that a sub n is equal to 30. So what that means is the 10th value in this sequence would be 30. Right here would be 30. Okay, so now that we've finished off on the theory part, let's go on to a practical problem. We're going to go on to AMC 10, problem number 7. It's a 2015 AMC. So here, let's figure out what they're asking us. So we can clearly tell off the top that it's not asking us to find the nth term. So pause the video and figure out what they're trying to asking us. I'll give you 5 seconds and then. Okay, now that you're back, let's figure out and let's break down what this problem is asking us to do. So clearly it's not telling us to find the nth term, but it's telling us how many terms are in the sequence. So it may seem a bit confusing at first, but it's basically using the same formula, just by instead of solving for a of n, we would solve for n. So let's do the same steps as before. Step 1 would be defining the variables. Step 1, defining variables. So what would be a sub 1 in this case? It would be 13, because that is the first term in the sequence. A sub 1 is equal to 13. What would be n? N, clearly, we don't have it here because we're trying to solve for n. So n is the unknown value here. But we do know what a sub n is. A sub n is 73. Think of it like 73 would be the nth term in a sequence. So we have a sub n, but we don't have n. And we're using a sub n to solve for n. So a sub n would be 73. And then finally, d, or the common difference between all of these variables, is 3, just like the last problem. So we see that the common difference is 3, so d would also be 3. D is equal to 3. So how does defining variables contribute to this whole step of trying to solve this problem? So what defining these variables allows us to do is that with these variables, now we can plug these values in and we can isolate the variable n, which allows us to get the answer of how many terms are in the sequence. So assuming that 73 is the nth term, if we find which term 73 is, we will know how many terms are in the sequence because it is the last term in the sequence. So if 73 is the 40th term, there'd be 40 terms in the sequence. So let's go on to step 2. Step 2. Step 2 is to plug these values in, just like the other problem that we did. So now, what is our formula? Let's recap. So our formula would be a sub n, which is 73. So 73 is equal to a sub 1 plus n minus 1 times d. So it'd be a sub 1, 13, plus n minus 1 times d, which is 3. We don't need a multiplication symbol here because when you have parentheses over here, as you can see, you don't need to put the multiplication in it. It just by default would be a multiplication. So 73 equals this. So now what we're going to do is, to do this, we're going to have to isolate n. So step 3 involves the process of isolating the variable n. Step 3, isolate n. So what we would do would be to subtract 13 from both sides. So let's just rewrite this equation. 73 is equal to 13 plus n minus 1 times 3. So what we would do is we would subtract 13 from both sides. Subtract 13. Just run it right on top. And then we're going to see that it would be 60 is equal to, since these two just cancel out like that, positive 13, negative 13, so it'd be 60 equals to n minus 1 times 3. Okay, so now that we have here, we're going to divide both sides by 3. So divide both sides by 3. So that's going to lead us to 20 is equal to n minus 1. We don't need parentheses around the n minus 1 now because we don't have a number that we're multiplying by, so we don't need the parentheses. So now the last step in isolating the variable n is to add 1 to both sides. I'm not going to write this step out up there, so I'm just going to write 21 equal to n is equal to 21. So there are 21 terms in this sequence, and 73 is the 21st term. So yes, this is indeed the correct answer for AMC 10 Problem 7 2015. And I hope you guys learned from today's session, and I hope you guys enjoyed learning with me. Thank you for listening. Goodbye.